All right, so welcome to day 1 of Algebra 2. We are beginning Unit 1 with a little bit of review just because it's been summer. We probably don't have all of the same math knowledge we did since the last time I saw you. So we just want to start with a little bit of review and make sure that we know what we're talking about. So the first thing I want us to talk about is something called like terms. Yes, like terms. Do any of you know what a like term is?
It's two terms with the same negative and positive.
Very close. Not negative and positive.
Should be with the same letter.
The same letter. And the same, there's one more thing. I don't know if you remember. It's a little thing.
Exponent.
Exponent? Yes. Okay, so I'm going to write a little definition here for you. Like terms are numbers with the same variable. Remember, variable is a letter. So numbers with the same variable and the same exponent. And what's an exponent again?
The little number 2 on the side of the number.
Yeah, it could be the little number 2, could be a number 3, could be numbered 5 million. An exponent is just like that little number. So I'm going to give you examples.
Or squared.
Yeah, or squared, or cubed. Absolutely. So, for example, 3x plus 5x minus 2x. First of all, are these like terms?
Yes.
Yes, they are. They all have x. And there's no exponent, but technically we could think there's like an invisible 1, x to the first power, x to the first, x to the first. So they match. Now, since they're like terms, can I simplify this expression here?
Yes.
I can. What would I do to simplify this?
3 times 3.
Oh, I hear add. I heard multiply. Which one's
You
correct?
add them all together.
Add them together. Now I know the x can be confusing because that looks like, oh, 3 times, wait,
10 to the 10 to the
3x.
third power, right?
Ooh, I see what you're trying to do here. To the third power. We're stepping ahead of ourselves. Like terms, we're not going to change the exponent or the variable because we're just adding and subtracting here. So we have 3 x's, and then we're adding 5 x's. What's 3 plus 5? 8x. So now I have 8 x's and minus 2x. So 8 x's take away 2 x's. What do I have left? 6x. 8 minus 2 is 6. So because these are like terms, we can add and subtract them. That's all we're doing. We don't change the exponent. We don't change the variable. We just change the numbers, the big numbers, the coefficients. Let's look at another example. What about 4x squared plus 6x minus 2x squared plus 3x? For this problem here, are these all like terms? No. Why not?
Because you have 4x squared and minus 2x squared are like terms.
Yes.
Because of the variable.
Yes, the variable. The variable is not the same on all of them. They do have the same, or not variable, sorry, exponent. All of them have x, so yeah, that's the same, but they don't all have the 2, the squared exponent. So 4x squared, you're correct, Titania, 4x squared and that negative 2x squared. These are like terms. These go together. Do I have other like terms?
6x.
Yep. 6x and 3x. So this is where I like to use colors to kind of help me keep things in order. So what would I do then, since I don't have like terms all in order? How could I simplify this? Go ahead, Titania.
Add 4x squared and subtract 2x squared.
Yeah, okay, so let's bring down the like terms. Let's combine the like terms. 4x squared minus 2x squared. Okay, and what would that give me?
Positive 2x.
Yes, 4 minus 2, just positive 2x squared. And now what?
You bring down 6x plus 3x.
6x plus 3x. And 9x. Good. So, I have 2x squared. And I have 9x. What would my full simplified expression be?
11x squared.
Oh, can I combine these?
No.
No. I can't combine them. They have a different exponent.
So those are the answers.
It'd be 2x squared plus 9x.
Yes, we have to put them together with a plus sign in between so we can simplify that expression. So it'd be 2x squared plus 9x. That's our answer, and we cannot go any further because they don't have the same exponent. They're not like terms. Okay. Let's do another one similar to that. What if I have negative 3x to the third power plus 2x plus 10x to the third power minus 5x. This one's tricky. This one is tricky. I'm gonna give you guys a minute to see if you can kind of get a start. See if you can figure out what we're gonna do here.
Taylor, is this live? Is your video live or just recording?
It's just recording. Yeah, I have to post it on YouTube after. But here, I'll pause it while you guys are working for a second. Okay. All right. Natalie, can you tell me what you did and what you think the answer might be?
You want the first step or like
However you want to give it to me.
So it's negative 3x to the third power.
Okay, negative 3x. Go ahead.
10x to the third power.
Yes.
And it gives you 7 to the third power.
Perfect. Okay, so Natalie did the negative 3x to the third power and added 10x to the third power, and you said that was 7x? Okay, perfect. 7x to the third power. And what'd you do next?
I didn't fully get that far, but I did
That's okay.
2x
Uh-huh.
minus 5x.
Perfect. 2x minus 5x. And that would give you negative 3x. Good. Okay, so we have two terms now. We have 7x to the third power. We have negative 3x. How would I put these together?
You write in 7x equals minus 3x.
7x what? To the third power. Good. Minus 3x. Good. Why don't we have to put a plus sign?
Because it's not a negative number.
Yeah, it's a negative number, which is, if you do plus a negative, it's subtracting, okay? Just write 7x to the third power minus 3x. Perfect. Okay. So, whenever you have the same letter, the same variable, and the same exponent, you can put them together by adding and subtracting. One more. What if I had something like this? 4y plus 2x minus 3x squared. Oh my gosh. I'm giving you something crazy. Minus 2y. Okay, yes. Here. With a problem like this, what would we do first?
Your like terms.
My like terms. Okay, so if we start with 4y, Kelsey, can you tell me what I would do next?
Okay, so I subtracted 2y from 4y.
Yes. So 4y minus 2y first. Good. 4y minus 2y.
It's 2y.
And that is 2y. Okay. Now what?
And then you literally just bring everything else down.
Ah.
Because nothing else can combine. There are no more like terms.
Yes. Okay, so this one was tricky because even though these next two terms are both x's, they're not like terms because they don't have the same exponent. This is just 2x. This is 3x or minus 3x squared. So we can't combine them. We're just going to bring them down. 2y plus 2x minus 3x squared. And that would be your answer. Yep, that's your simplified answer there. Okay. How do we feel about like terms? You think we understand what these are? Okay, good, good. All right, I see a few people still writing. I'll give us just a second to finish this page up, and then we're going to move on to the next review item. I'm going to turn my page. Okay, let's see. Pause for just a moment. Okay, so I'm going to go ahead and flip my page. And every time I flip my page, I do another little miniature title just because I tear these out and I don't want to lose track of what we're doing. So I'm just going to write Algebra 2, Unit 1. This is page 2 for me. And Day 1 notes continued. Okay, so the next thing we want to talk about is distribution. 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 Does anybody know what distribution is? Yeah, if you've had me, you have got it in your notes somewhere. Distribution. Let me give you an example. It's kind of hard to explain. It's easier to just see it.
That's exactly what I was just
saying. Math is one of those things. Sometimes it's easier just to look than to explain. Example. If I wanted to use distribution, what would I do?
You want to take your bigger number times the numbers that's inside of the quotation.
Yes, 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 yes. Distribution, a fancy word for multiplying. You are going to do this. Let me write kind of the definition to the side. Multiplying. I'm just going to write multiplying. So, with distribution, what I'm really doing here is I'm taking 5 times x, and I like to draw these arrows. This helps me, so it might help you. 5 times x, and, so let me write that, 5 times x, and I'll just bring down that plus sign, plus 5 times 3. Okay. What's 5 times x? 5x. If I have an x and I have 5 of them, I have 5x. That's just, you know, 5x. Bring down my plus. What's 5 times 3? 15. 5x plus 15. That's it. That's your distribution. Well, let's see. How about -3 and then 2x plus 4. Okay. Now that's a -3 on the outside.
-6x.
Ooh, yes. So the first thing you did here, -3 times 2x. So I'll write that. You do not have to write these little steps. I'm just doing it while we review. -3 times 2x, and you said that gave us -6x. And -3 times 4. So -3 times 4. Good. That is -12. And that's it. That's your answer. -6x minus 12. Not so bad, huh? Not so bad. Also, you might notice if you've been in this class before, normally there's little calculators everywhere. I had to donate those to our new math teacher. She did not have calculators. We do have available over on the computer cart tons of calculators. They're very nice. It's the graphing calculators. If you would like to grab a graphing calculator, I don't know, I like to type in even the -3 times 4. It's like, I know that's -12, but I want to make sure, you know. So if any of you want a calculator, I'm going to pause the recording. All right, so now, what if I gave you a distribution problem like this? What if it was 2x 4x plus 3. Now this one's tricky because one of the things you'll need to know to do this, I haven't reviewed with you yet. We did cover this in Algebra 1, but it has been a while, so it's okay if you don't remember. We'll go over it.
You add the 4x and the 2x together?
Kind of. You are going to still multiply like normal, but you are going to add something. The x's, those exponents. Ooh. Okay, so here, let's talk about this. We're going to do the same process. 2x times 4x.
So 8.
So 2x, yeah, times 4x. And whenever you take a variable times a variable, you are adding the exponents. Now, you don't see an exponent on these. So remember, that's an invisible 1. Invisible 1. 1 plus 1 is 2. So 2 times 4 is 8. X times x is x squared. X to the second power. Okay? And then next, 2x times 3.
That'll be 6x.
6x. Good. You just carry that x right over. Plus 6x. And I'll just bring that down, plus 6x. And that's your answer. Good. Good, good, good. Yeah. Now, if you did forget, and you're like, oh my God, how am I going to remember that? Guess what? We're about to go over that. Okay? I just wanted to give you a sneak peek before we do. So, scooting down, let's do one more. Well, 2 more little review items. And then this will be the end of the review that should get you up to speed on what you need to know for Algebra 2. The next thing, we're going to be talking about exponents. Exponent multiplication, which is what we just did. We just multiplied exponents. That's a big word. Exponent multiplication. And I'm going to write a little formula. If you find this useful, great. If you don't, you can ignore it. Let's see. Here is the formula I will give you. So we're going to write x to the a power times x to the b power equals
C. X to the C.
not quite x to the a plus b. So if I have, we're going to see if we can use this formula. I'm going to give you a problem. X to the 4th power times, now remember parentheses is just like distribution, it means multiplying. X to the 4th power times x to the 3rd power. What is that?
2x to the 7th power.
Now wait a minute.
Or x to the 7th.
X to the 7th power. Yes, there's no numbers in front. It would be like an invisible 1 again. 1 times 1 is 1. So x to the 4th times x to the 3rd is x to the 4 plus 3. You don't have to write this step. This is just if it helps. X to the 7th. You see that? Some funky rules. We just follow them. How about x to the 12th power times x to the 52nd power? Looks crazy, but you can do it.
X to the 34. No, 64.
X to the 52 plus, or sorry, 12 plus 52. And I believe you are correct. Oh my gosh, I can't write. Equals, yes, x to the 64th power. Very good. So you're just adding. And then I'm going to give you one more. Do this one on your own. Do not say the answer if you know it. I know y'all do know it. Just don't say it yet. Let's do x to the 105th times x. Yes, I am. I'm making it tricky for you. All right. X to the 105th power times x to the 99th power. Don't say it out loud. See if you can get that. I know you can. Then I'll pause this for a minute. Okay, raise your hand if you know it. Raise your hand if you know it. Jessica, what is it?
It's x to the 204th power.
X to the 204th power. Perfect. Okay, and I'm just going to write that again. 105 plus 99. That's all we did. We just added the exponents. So if it helps to remember this method or this trick, maybe make a little note here. I'm going to say to multiply exponents, add You're just adding the numbers. Add the little numbers together. All right. I see a few people still writing. I will wait a minute and let everybody get caught up on that. And then one more. We're going to talk about exponent division next. All right, so we've done exponent multiplication. Now I'm going to start a new page. I'm going to retitle Algebra 2, Unit 1. This is page 3 for me. And day 1 notes continued again. Okay. Last but not least, exponent division. Exponent division. Okay. Now, something to keep in mind with division is, even though we know the typical division sign looks like this, and it'll be something divided by something, in real life and in most math problems, you are going to see division written more as a fraction. You'll see what I mean when I write the examples here. We'll start by using the regular division symbol, and I'm going to give you another little formula. X to the A power divided by X to the B power equals X to the, does anybody know? A something B. A minus B. It's the exact opposite. Exact opposite. Instead of A plus B, we just do A minus B now. Not too bad. So, even though I wrote it out like this, this is how you will normally see it. X, X. The A will be on top, the B will be on bottom. A minus B. Okay? This is the same thing, just written differently. So I'm going to circle these so we can see that they're separate. Okay. So these are the same, just written differently. Same. And I'm going to start with something like this. Let's say I have X to the 32nd power divided by X to the 12th power. Now don't say it out loud. If you have your answer, don't say it out loud. Try to see if, without me running through this example, see if you can figure out what this answer would be. And once you think you have the answer, give me a thumbs up. And I want to wait till I see a bunch of them. Okay, good, 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 good. Okay, I see a lot of us getting it. Good, good, good. Okay, good, good. Okay, would anybody like to share? Titania, what are you gonna do?
You would subtract 12 from 32 and you get x to the 20th power.
Yes. Yes, yes, yes. This is my A. 32 is basically A. 12 is my B. You can remember it this way. A is always on top, B is on the bottom. Bottom B, okay? You're doing A minus B. So, we're really just doing x to the 32 minus 12. Okay, and if you want, I'm going to do this like this. 32 minus 12. 2 minus 2 is 0. 3 minus 1 is 2. So our answer is x to the 20th power. Simple enough, right? We got it. We got it. Now, the only part that it can get a little tricky on is something like this. I'm going to give you one more example here. What if I gave you 25x to the 4th power? Now I gave you a coefficient, a big number, not an exponent, divided by 5x to the 2nd power. We don't just have exponents. Yes, Natalie.
Oh, I knew the answer. I think
Tell me about it.
I think.
Okay. Let's see.
So I got 5x to the 2nd power.
Yes. 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 How'd you get that?
Divide 25 by 5.
Uh-huh.
And then subtract 2 from
Yes. Okay. So, right. Look at you go. I love it. So, this is just a big division problem. If you have whole numbers, these coefficients, do that first. Okay. 25 divided by 5. I'm going to write that. 25 divided by 5. Well, that's 5. Okay. Now you use that exponent division rule. 4 minus 2 is 2. So 4 minus 2. 5x to the 2nd power. So that's how we got that. Very nice. Very, very nice. Okay. So, go ahead.
And another way too is to find the answer if you take 5 times 5, you're going to get 25.
Very true. Very, very true. Yes. That's a good way to think of it. 5 times 5 is 25.
That's not it.
Yeah. Good deal. Okay, how do we feel? Scale of 1 to 10.
I'm at a 10.
10. Oh, yes. It makes me happy. Love it. Okay.
That's my first writing side by side.
Yes.
Top to bottom.
Good. Okay. I am going to pause just for another moment. Let everybody get caught up on this page. All right. So, that is quite a bit of review here, and now we're going to use that to introduce a very important topic. Next page. This is page 4 for me.
Just pay.
Yes.
Are we doing graphing in this session too?
No, not today.
Okay.
Not today.
So we are.
At some point, we'll do a tiny little baby bit of graphing,
Okay.
but I don't have you guys do that much.
That works for me.
Graphing in Algebra 2 is a lot. I will show it to you, I'll introduce it to you, but this term I'm really thinking about just showing you how to use the graphing calculators that will graph for you. It's very nice.
That's wonderful.
It is wonderful.
I vote for that.
Yes. I think I just decided just now that's what we're going to do. Unit 1, page 4. Okay, day 1 notes continued again. Okay. And I'm going to reintroduce a word some of you probably know. And if you don't know it, that's okay. It doesn't mean that you're behind, because you're going to learn it right now. Binomials. What's a binomial? Anybody know? Binomials.
It's an equation with two, I can't remember the word right now, but two numbers
Yes.
and like coefficients.
Yes.
Whatever, yeah.
Terms.
Terms.
Two numbers are terms. This is just yes, terms. So here's a great way to break this up. B-I, means two. Yes, it means two. Nomial means numbers or terms. Terms or numbers. And the reason we say terms instead of just numbers is because sometimes it's not just a number. Sometimes it'll have a variable or an exponent. But the key is there's two of them. There's just two. So an example of a binomial would be 5x squared plus 3x. How many terms are there? Two. So it's a binomial. That's it. This is a binomial. Two terms. So I will say that's a term. That's a term. 5x squared is a term. 3x is a term. And there's two. There you go. That's a binomial. Now that we know what a binomial is, we're going to talk about multiplying binomials. Big words today. Okay, and then I will teach you two methods. I'll pause again because we're speeding through. All right, so multiplying binomials. I like to teach two different methods. There is what we call the FOIL method. F-O-I-L. You know what it is. And then there's the box method. So what I'm going to do for the rest of my page is I'm going to take a ruler. Let's see, what's about the middle of this? I want to draw a line down the middle. Let's see. I don't know. Like here. Gosh. 8.5. 4.25, so like 4 1/4. Okay, that's about the middle. That ain't perfect, but you know. Okay. So I'm going to draw a little line, and we will talk about the FOIL method first. And if you are wanting to make a nice, beautiful straight line, there are rulers at your desks, so feel free to use whatever's at your table. That's for you guys. And let's talk about FOIL first. So FOIL is an acronym, which means each letter, F-O-I-L, they stand for something. They stand for another word.
First, outward, or last.
Yes, the F in FOIL is first. So let's see. I actually, before I, no, I'm going to write it. Okay, first. Okay. The O is for outer. And this will make much more sense when I give you an example. Let me zoom in. first outer, I for inner. And L for last. Let's use blue. Okay. And here is how that would work. So let's write an example below. In that example, we're going to have two binomials in parentheses beside each other, and we'll start with some simple binomials so we don't get too complex too quickly. Let's do x plus 2 times x plus 3. Now, if you already know this, wonderful. I love that. Let's not jump ahead too fast and get too excited, because I know for some of us, this might be the first time you're seeing this, or it might be the first time you've seen it in years, or, you know, sometimes it's good to just have a nice slow explanation. But, you know, I could be wrong. Maybe everybody knows this, and I don't know. We'll see. So, first, when we talk about first, we're talking about the first term of both binomials. So the first term of x plus 2 is x. The first term of x plus 3 is what? Also x. Good. So these are the first terms. Okay? So up here, I could write x times x, and we're multiplying, okay? We're multiplying. So first I have x times x, okay? Next we move to outer. Now when we talk about the outer terms, we're talking about the outer, the very farthest outside terms. So that would be the x and the 3, right? Okay, so we're going to take x times 3. Okay. Now my inner terms, what two terms are on the inside? Yes. 2, I'm going to do it on top now so my colors don't get all mixed. 2 times x. These are my inner terms. Oh, I'm using the wrong orange. I thought that looked weird. 2 times x. And my last terms. 2 is the last term of this one. 3, good, is the last term of the next one. So 2 times 3. Yes. So we're doing 4 problems here, basically. Do you have to write out the 4 problems? No. Most people, when they use the FOIL method, at some point, you know, you get kind of automated with it, and you'll think, okay, x times x, x squared, yep, I got that. You know what I mean? You don't always have to write it out, but if it helps you, do it. I know it takes a little longer, but I would rather you take forever and get it right than rush through it and get it wrong. So take your time. Take your time. We're not in a race. Okay? So once you've kind of seen all these, let's look at what our answer might be. Let's go to the first terms. We did x times x. What is x times x? X squared. Good. What is, now I'm at the outer, x times 3?
3x.
Yes, 3x. 3x. my inner term's 2 times x. What's that?
2x.
2x. And my last, 2 times 3? 6. Good. So I have x squared, 3x, 2x, 6.
So x squared plus 3x plus 2x plus 6.
Yes,
Why
yes,
do you like terms?
yes. I'm actually glad that you didn't yet because I like to do it step by step. So let's write out exactly what you said, Titania. I'm going to write these out with plus signs in between. We have x squared plus 3x plus 2x plus 6. Okay.
So it'll be 5x squared plus 5x plus 6.
Yes, 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 yes. So here is where we would go next. After you've done your multiplying, there is almost always going to be like terms in the middle. These two middle terms, the inner terms, are usually going to be like terms. And why are these like terms?
Because they have the same exponent.
Yeah, same exponent, same variable. They're both just x. So I can just add 3 plus 2, and it's 5x.
You bring everything else down.
And you bring the rest down. Good. So I have x squared plus 5x plus 6, and that is my answer. Very, very good. Now, you see why it was important to review all those other things? Because they build. They build. So, this might seem like a lot if it is the first time you've ever seen this, or if it's the first time in a while you've seen it. But I promise you, anyone in here that has learned this through, you guys are going to be like, boom, 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 boom. You're going to get it once we have a little more time to practice. I really just want to introduce this to you today. Okay, so if you are feeling overwhelmed, it is all right. Tomorrow we will give a little more time to this. Okay. And then the very last thing now would be the box method. It's the same thing, it's just written different. Exact same thing. And I'm going to use the same example in everything. Okay? For the box method, you're going to draw a box. For my visual learners, this is usually the method that clicks and it makes a lot more sense. So I start with a box. I split it down the middle both ways, and so it looks like a window.
4 squares.
4 squares, yes. Okay, and I'm going to use the same example, so I'm going to write that again. X plus 2 times x plus 3. Okay, and here is how we use the box. I'm going to zoom in on this. So instead of having to go through and draw all these arrows and figure out what goes with what, I have a lot of students that like this method better, but you know, everybody's different. We're going to take our first binomial, x plus 2, and we're going to write each term above the boxes on top. So x plus 2. Okay? The next thing we're going to do is we're going to take the second binomial, x plus 3. We're going to write it over to the side here. Good. We're going to separate the terms. So x on that first box plus 3 underneath, just like that. So now I have x plus 2 and x plus 3. Now this looks a little funky, but stay with me. If you've ever used a multiplication chart, it's the same thing. Because here's what's happening here. 1 times 1 is 1. 1 times 2 is 2. I don't know, 2 times 3 is 6. You can kind of take the things on the side, and wherever they meet is the product. It's the multiplication problem. So we're going to use that same concept here. I want to know x times x. What's x times x?
X.
X squared.
X squared. X squared. Don't forget the squared. That's all
I
right.
don't like this.
X squared. X times x. That's x squared. Now x times 2. 2x. And if it helps, you could even bring down that little plus 2x. Okay. And I've done my x times x times 2, done with the x. Move down to 3. 3 times x is 3x. So plus 3x. And last but not least, 3 times 2. Oh,
5,
6. Multiply.
6. Ah.
I think me putting the plus signs probably threw you off.
Okay.
You don't have to do the plus signs. I was even thinking as I wrote them, somebody's going to want to add. That's my fault. So 3 times 2, yes, it is 6 plus 6. So from here, how we find our final answer is we just,
like terms.
yep, you like terms inside the box, which are almost always going to be these diagonals, 2x and 3x. Just like 2x and 3x were the same ones in the FOIL method.
So you just add them.
Mm-hmm.
It's 2x plus 5x.
Yes.
6.
So I have 3x plus 2x, and that is 5x. And I can just bring all that down with my other terms. X squared comes down out of the box. Plus 5x, that comes out of the box. Plus 6, that comes out of the box. And that would be my answer. And it's the same answer we got for the FOIL method. Look at that. It's the same. So they both work. They both work. It's just whatever you prefer. Okay. I know that the binomials is a lot more steps than all the other things, but how are we feeling? You feeling okay? We're alive? Yes?
The review helps a lot.
Yes. Yes. That's why I do it. That's why I do it. Good. I'm glad it helped you guys. Okay, so this is all I'm giving you today. Please know the only thing that's due for today is that day 1 exit ticket, so the signature sheet of the classroom agreement. Just make sure you sign it and turn it into the turn-in tray under the board. It's due on Friday. If you don't know what days you won't be here yet, you can take it home and figure that out and just bring it back to me by Friday. But that is it. I'll see you guys tomorrow.
Okie dokie.